Hi everyone, I'm Mamu Minokamo. Thanks for tuning in. Today we're diving into serial communication, specifically RS-232 and RS-485, those so-called legacy technologies. You might be thinking, aren't those outdated? But surprisingly, they're still alive and well in many manufacturing sites and testing devices today.
Hey, long time no see. This might be a bit outside my generation. I wonder if I can keep up.
Oh wow, Takayama-san. It's been a while. No worries. No worries. In fact, learning about unfamiliar tech can be really fun. This time, I'm planning to release this program on GitHub and hopefully earn lots of stars.
Well, I'm the one who came up with this whole system, after all. Sure, it might not attract a huge audience. But honestly, I think earning stars on GitHub is way more valuable than going viral on YouTube. That said, since not many people are doing this kind of thing, getting lots of stars might be tough.
Oh, hey, Dad. All right then, just like you suggested, let's dive into the setup right away. It's been a while since I wrote this program, so there might be a few parts that differ from what you'll see in the video. But hey, we'll make it work. The code is split across several files, so I'll walk you through it step by step.
Oh, hey there. Looks like I made it just in time. You've only just started, right? You're setting up the virtual environment now, yeah?
Hi, Nakatsugawa-san. Wait, hold on. What's with that outfit?
Huh? Well, you did say we're covering old school tech today, so be prepared. So, I figured I should dress the part.
That's not exactly what I meant, but oh well. Anyway, let's get back to it. Creating a virtual environment helps keep your system clean and organized. In this program, there are a few required packages, so we'll install them using pip.
I see. And since some packages might not be needed later, installing them in a virtual environment makes it easier to remove everything at once.
Exactly. In the video, I'm showing you which packages are needed. I've also included a requirements.txt file on GitHub, so you can set up the environment right away.
Sorry, requirements text. What exactly is a requirements text?
Requirements.txt is a file that lists all the Python packages used in this program. With it, anyone can easily recreate the same environment, no fuss.
Thanks, Oyaji-san. I'll look it up as soon as I get home.
Thanks, Oyaji. Nakatsugawa-san, I know you already knew that. You said it for the viewers, didn't you? Really appreciate it. This PC has 2 serial ports, but if yours doesn't, you can use virtual serial ports instead. All right, everything's ready. Let's launch the program and run a quick test. Don't worry, there's an English version available too. There are actually multiple programs, so I'll walk you through them one by one. First, let's launch the Receive Side program. Don't worry, the dashboard is fully available in English too. As I mentioned earlier, this was built a while ago, so the design might look a bit different now.
So that means the sending side runs on a separate PC?
Nope. Actually, you can run both sides on the same PC. Here's what that setup looks like.
I see. So you're connecting 2 COM ports on the same PC with a cable.
Exactly. But since many modern laptops don't have physical COM ports, you can use a virtual serial port driver to create a pair of virtual COM ports instead. That works the same way. All right, now let's test the transmit side program. For convenience, we'll run it from PowerShell this time. The reason is, both the transmit and receive programs are in the same folder. But in VS Code, opening the same folder in multiple windows is kind of a pain. I mean, you can do it by tweaking the settings, but yeah. I'm talking about settings in VS Code. It just turned out to be faster and simpler to use PowerShell. shoot, looks like I ran the script without activating the virtual environment. That caused an error. Let me activate the virtual environment and rerun the script.
Whoa, something just popped up. I don't really get what it means, but is this impressive or something?
What's happening is, the transmit program is sending data right now, and this window is receiving and displaying it in real time. In the upper section, the received data is neatly categorized by timestamp, direction, and content. And in the lower section, you can see the raw messages in a log-style view.
So this is basically data transmission and reception within the same PC.
Exactly! You've got it! But this setup alone is a bit limited, so next we'll try running the test in a Linux environment. Just a heads up though, on Linux, the concept of COM ports can be a little tricky, so we'll need to be extra careful there.
Whoa, you're doing this in Linux too? That's gonna be tough. Are you sure you can handle it?
Wait, seriously? Is it that hard? I'm already starting to lose track of what's going on. This is totally going to become one of those videos no one watches, huh? Mamu-san, you're clearly not in this for the YouTube money.
Looks like you're about to start the Linux communication test, huh? All right then, I'm jumping in from here. Let's get this thing rolling. Yeah, you can count on me.
Oh hey Seki-san, glad you're here! If I get lost with the Linux stuff, I'm counting on your support, okay? So, what we're doing right now is checking the ports and setting the permissions, just like I explained in the slide earlier. If you weren't paying attention, feel free to rewind a bit and go over that slide again. Also, I've included a super clear explanation with links in the video description, so if anything's confusing, you can always check that out too.
Yeah, this is tough stuff. I don't think I'll be much help this time. To be honest, I came here to learn too. So yeah, this is all new to me. I've got no clue. When it comes to serial communication on Linux, only Oyaji and Mamu know their stuff.
Oh, Seki-senpai, hey there! Honestly, I'm totally lost at this point. I'm kinda just here, without really contributing anything. Still, you're just as serious about learning as ever. Doesn't match your look at all.
Well, if it isn't Mizuki. Been a while. Save the commentary. And seriously, what are you even wearing right now? Whatever. This is no time to wimp out. Stay focused and keep learning. Don't run from it.
Haha. That was a fun back and forth between Senpai and Kohai. You two went to the same university, right? Though both of you have already graduated. Anyway, setting that aside, let's move on. We'll quickly create and activate a virtual environment here, so hang tight for a moment. If the virtual environment won't build properly, it might be because you're missing some Python packages. In that case, I'll walk you through installing the required ones too. All right. Next, let's double-check the port just to be safe. On Linux, you can use the dmesg command to check if the connected serial device is being properly recognized. Look, right here. You can see TTYS0 showing up. This corresponds to what's commonly known as COM1, and it means the built-in serial port on the PC has been successfully detected.
Whoa, this is seriously impressive. I've been messing around with that trending tool, Claude Code, lately, but looking at this makes that one feel pretty simple, at least visually speaking.
Yeah, I get that. Claude Code runs in a pitch-black terminal, so for beginners, it can feel a bit intimidating. Technically speaking, this setup's actually simpler. But these days, unlike the old times, tools are designed to be way more user-friendly.
I see. That's a calm and rational take. Looks like I'll need to shift my thinking a bit.
Exactly. As long as you've got the motivation, things tend to work out. Oh shoot, this one's the old version of the program. Let me go ahead and switch to the new one.
Yeah, No choice but to face it.
That's right, maybe I got the wrong idea about AI.
I thought it could just handle everything for me, no problem. But the truth is, technology, at its core, is supposed to be hard. I guess I kind of forgot that. Thanks, Oyaji, you reminded me.
I don't really get AI all that well myself, but the fact that you could recognize that, that's honestly impressive. All right, the Linux side is all set up to receive. Now we'll switch over to Windows and send some data for a quick communication test.
Wait, seriously? I'm barely following as it is. And now we're testing between different operating systems?
I feel like I'm just going to end up watching silently at this point.
Yep, that's totally fine. If this gives you the idea like, oh, so that's one way to do it, then that's more than enough. Now then, on the Windows side, we're using a mechanism called a named pipe to communicate with Linux. Each direction, sending and receiving, has its own virtual channel, and data is transmitted to Linux through those. Once it shows bidirectional pipe connection established, it means the message has actually been sent. This method is really handy when testing communication between virtual machines or across different environments. All right, now this is where the real stuff begins.
Wait, seriously? There's still more to cover? I'm already full just from what we've seen so far.
Oh, there's definitely more. We haven't even tested communication between dashboards yet. Remember? So far, we've only been sending test data using a plain Python script. But since we went to all the trouble of building the actual dashboards, don't you think we should at least check if they can properly talk to each other? Also, I want to introduce another method, how to use IP addresses for communication. Just stick with me a little longer, okay? Oh, whoops! Now I'm going to launch the receiving server on the Windows side and send data from the Linux side this time.
Heck yeah, I'm totally fine with that. This is actually starting to get pretty fun.
Thanks a bunch. All right, the receiver on the Windows side is ready. Let's try sending data from the Linux side now. It's just a simple little script on this end too.
I kind of want to be useful, so I've got a question. Oh, is serial communication different from more modern ways of transferring data? Well, I get that we're just doing the reverse of what we did earlier.
Whoa, that's a tough one, Oyaji. You're up.
All right, simply put, serial communication sends data one bit at a time through a single wire. Modern things like networks or USB use much faster, more complex methods. But serial has the advantage of being simple and easy to control. That's what makes it so useful.
Thanks, Oyaji. Really appreciate it.
Thank you, sir.
To be honest, I wasn't super confident about that part either, so your explanation really helped. All right, next we'll be testing communication between two dashboards. So far, we've been using pre-written scripts to send data between systems. But this time we're doing something new. We'll manually type a message and send it in real time. In other words, whatever you type will go straight to the other side.
Whoa, this really feels like an actual communication is happening. I'd love to see it in action.
Hey, why is there an IP address showing up?
Aren't we using serial communication?
That doesn't make any sense.
Well, this is, actually, I'm not sure how to explain this. Oyaji, could you take over?
Oh great, me again? Am I the official explainer now or what? All right, listen up. This dashboard supports both serial communication and network communication. In other words, it can connect via USB or COM ports, and it can talk to other PCs using IP addresses.
Thanks again, Oyaji. That was a huge help. So now, on the Windows side, all we need to do is enter the Linux machine's IP address, and we're good to go. Please don't ask me what an IP address is. We're going to skip that part, okay? Anyway, let's try sending a message just for fun.
Oh, hey. Looks like it's working even though the devices are on different segments. Must be because there's a virtual switch or router acting as a bridge behind the scenes. Well, I'll leave the deep dive for another time.
Exactly. Gotta appreciate how robust modern tech has become in handling stuff like this. Oh, looks like the message was sent successfully.
What exactly is a segment? You're keeping all the good stuff to yourself. That's not fair. Weren't you the one always saying, you can't master generative AI without understanding the basics?
Yikes. Guess I said too much again. All right, I'll explain it. A segment is, roughly speaking, like a group of devices on the same network. That's not super clear, is it? It's kind of hard to explain just by talking. Better check out the video.
Oh, hey, that's a really clear diagram. Did you make this just for us? Thanks a ton.
So basically what you're saying is, if two devices aren't on the same segment, they generally can't communicate, right? And earlier they could communicate because, there was some kind of something.
That something, yeah. I phrased it a bit technically before. But to put it simply, that something is a router. Routers make it possible for devices in different segments to communicate with each other. Of course, it needs the proper configuration.
I was listening from the side, and I learned a lot. I definitely need to review this while it's still fresh in my mind. Now, I finally understand what you meant earlier when you said this is still a relevant technology today. In other words, it means we can connect to older machines, receive their data, analyze it, and even output it. Right?
Exactly. I'm impressed you picked up on that, and your summary was spot on. All right, let's wrap things up for today. See you all next time. Goodbye.